So what is massive MIMO? Multiple input, multiple output. MIMO stands for uh, so it's a wireless technology where multiple antennas are used at both the transmitter like a cell tower and the receiver like the user equipment. So massive MIMO means using a huge number of antennas, much more than usual, sometimes dozens or even hundreds. But the antennas are small, not physically massive. Why there is a use of massive MIMO? Using many antennas, uh, the net the network it will send the data to multiple devices at the same time faster and it is more reliable. Why the massive MIMO it is important concept. It is a key technology for new 5G networks, especially in millimeter wave. Millimeter wave frequency is very high speed but short range. Sub 6 gigahertz lower frequencies, longer ranges but slightly lower speed. So massive MIMO it will help uh, in boosting the network capacity and coverage, making 5G fast and more reliable. So antenna array. Array means group of elements, group of antennas. So large in number, massive MIMO it will use lot of antennas greater than 8 antennas, meaning way more than 8. It is not generally massive in size, even though there are many antennas, each one is small, the entire array can fit on a tower or even inside a building wall. It is fully digital steerable antennas. Each antenna can adjust its signal direction electronically without needing to move physically. So it will serve many users simultaneously because the system can point different beams at different users. Many people can use the network at once without slowing each other down. Antenna signals adaptable by the physical layer. The system dynamically it will change how it sends the signal based on where the user is or how they move. Azimuth and elevation beam forming. Azimuth means controlling the beam left or right horizontal. Elevation means controlling the beam up and down vertical. Together this is a 3D beam forming. Azimuth and elevation combined is 3D beam forming. Beam forming uh, means it's focusing the wireless signal into a narrow beam like a spotlight instead of sending it everywhere like a light bulb. This makes communication stronger and more focused. Beamforming I have already covered in the previous videos. So other names for massive MIMO are LSAS, large scale antenna systems. Just another word of saying we are using a very large number of antennas. FD MIMO, full dimension MIMO, highlights that antennas can steer beams in all the directions up, down, left, right, 3D control. So imagining a cell tower with many tiny antennas, some beams are pointed up to reach people in tall buildings, elevation beamforming. Some beams are pointed left or right to reach people on the streets, azimuth beamforming. All users get strong signals without interfering with each other. So what are FD MIMO, EFD MIMO, 5G, MIMO? FD MIMO LTE release, it is in the release 13. It's defined in the release 13. Full dimension MIMO early stage. It's a basic 3D beamforming. EFD MIMO LTE release 14. Enhanced full dimension MIMO improved version. It's a improved version of FD MIMO. 5G MIMO NR release 15. Massive MIMO for real 5G networks much stronger and smarter. Comparing the features of these one by one. So the number of antenna ports present in FD-MIMO, it is really it's in release 13. So there are 16 CSI RS ports for channel measurement, 8 DMRS ports for sending data. CSI channel state information reference signal ports for channel measurement 16 in FD-MIMO, 8 demodulation reference signal ports for sending data in FD-MIMO. EFD-MIMO, it's in release 14 and 32 channel state information reference signal ports. So 32, it's a double improvement. Still, it has 8 DMRS demodulation reference signal ports. And 5G MIMO release 15, it has 32 CSI RS ports, same as EFD MIMO, and 12 DMRS ports, better for more users data. So over time, systems added more antennas and more ports to handle more users and a better accuracy. Coming to maximum number of downlink multi-user MIMO users or layers per UE. FD MIMO and EFD MIMO will have 8 or 8 or 1 or 4 or 2. Maximum number of downlink multi-user MIMO users or layers per UE. And 5G MIMO 12 or 1 to 4. So 5G MIMO can support more users and more simultaneous layers data streams. Coming to operational bands, FD MIMO and EFD MIMO. Uh, Sub 6 GHz lower frequencies wide coverage come under 6 sub 6 GHz lower frequency wide, it will have a wide coverage. 5G MIMO both millimeter wave very high speed short distance and sub 6 GHz operates in both. So 5G MIMO works on both the short range high speed and long range network. So 3D MIMO support all of them. uh, Means 3D MIMO support FD MIMO, EFD MIMO, MIMO support 3D for both up, down, left, right control. Coming to duplex modes, how communication happens, FD MIMO, EFD MIMO. Considering this both, if if in FDD separate frequencies for upload and for download, and in TDD same frequency for different time, as these are definition of FDD and TDD. And 5G MIMO, it supports TDD for millimeter wave and sub 6 gigahertz, and FDD possible for only sub 6 gigahertz. So simple meaning, 5G prefers TDD, time based sharing, but supports both. Coming to pilot based symbols used for signal measurements and adjustments. So downlink pilots ELFD MIMO, EFD MIMO use CRS, cell width, DMRS, CSI, RS. 5G MIMO uses CSI, RS, DRS, PTRS, and DMRS. And in coming to uplink pilots, all of them use DMRS and SRS. Simple meaning is that 5G, it will add PTRS and DRS to handle more accurate tracking and phase adjustments. It is important at the high frequencies. And G node B antennas, considering 5G base station antennas, it can go up to 256 antennas. Uh, Massive MIMO truly becomes massive in numbers. Considering all three FD MIMO, EFD MIMO, and 5G MIMO. FD MIMO, early 3D MIMO limited antennas. EFD MIMO, more antennas, better